Okay, so for this one, I remember this guy because I know what's on the bottom of secant. What's on the bottom of secant? It is cosine, right? 1 over cosine is the same as secant. And so what else has cosine on the bottom? Cotangent or tangent? Well, tangent is sine over cosine, right? So this would be tangent squared x. Okay? Now, how do we go farther along on this pathway here? We have cosine squared x, and this happens a lot. This strategy happens a lot. The strategy is change everything to sine and cosine. So if you're not sure what to do next to simplify, change everything to sine and cosine. Now this one's already cosine. How do I change tangent squared x into sine and cosine? It'd be sine squared x over cosine squared x. And if you were to multiply these, right, wouldn't you make this over 1 and then cross cancel those guys out, because you divide those each by cosine squared x and you would get sine squared x. Is everybody with me? Yeah. Okay, is that the answer is right there? Yeah. All right, sweet, we win. So these are, I like these problems. They're really simple, simplifying trig using identities. And so you got to think about substitution. You got to think about regular operations. Now, you guys just saw how I did it, right? Yes, sir. And if you understand that, cool. There's another way. I know some of you guys don't like it when I do this, but I'm going to do the other way. The other way is like this. You could take this secant, and you could take him out, and you could put 1 over cosine squared x, right? Because that's the same. And then can't I distribute this? What would I get? I would get 1, because cosine squared x times 1 over cosine squared x would equal 1. And then what would cosine squared x times negative 1 be? Negative cosine squared x. And what does that equal? What does 1 minus cosine squared x equal? Sine squared x. So you see how there's different ways to get your answer? This is the beauty about trigonometric identities. Oh my goodness, you will trip. Oh, I guess maybe it's only me because I'm pretty nerdy.